Good morning students, I am Krina Dayani and I am your chemistry teacher. We are at AriserTalent and now today we will going to discuss about the structure of atom. In the series we have completed our 4 models, that is Thomson's atomic model, Dalton's atomic theory, Rutherford's experiment we have studied, that is about the alpha scattering experiment, and we also discussed about the Bohr's atomic model. These 4 scientists gave different points about the structure of atom, and finally Niels Bohr's atomic model is adopted worldwide as a standard because it did not compete about any drawback of the other previous models. Now we are on our next topic, that what will be the electronic configuration of an atom. So our today's topic is electronic configuration. So students, what is electronic configuration? Electronic configuration is basically the arrangement of electrons in the shells of an atom. So electronic configuration is basically the arrangement of electrons in shells of atom. We know that atom have a different shells which can be designated as K, L, M, N. So the arrangement of electrons in the shell is defined as the electronic configuration of an atom. So finally last model, Bohr's model, is adopted as a standard model, and Bohr and the scientist named Berry both work on the atomic model, and they give certain rules for writing the electronic configuration of an atom. So electronic configuration can be returned according to Bohr-Berry scheme. Final model of atom was adopted as a Bohr atomic model and his co-worker Berry. So Bohr-Berry scheme is basically a scheme for writing the electronic configuration of an element. So electronic configuration can be returned according to Bohr-Berry model. So according to Bohr-Berry scheme, there are certain rules for writing the electronic configuration of an element. So we have certain rules for electronic configuration. Now our first rule is the number of electrons accommodated in any shell of an atom is 2n square. So the maximum capability of an electron to accommodate will be 2n square. So here our first rule is the maximum number of electrons in any shell of an atom will be 2n square. So it cannot exceed the level of 2n square. This can be understood with the help of an example. Suppose I have considered the atom with the nucleus in the center. Now what we will do, we will draw a different shells of an atom. So what we have considered nucleus in the center. Nucleus is basically the sum of protons and neutrons. And what will happen in these energy shells, electron will going to revolve. So we can define it as this is first energy shell, or we can say first energy level. This is second energy level. This is third energy level. And finally, we have fourth energy level. So, we have 4 levels in this diagram, and we can also say these levels can be K, L, M and N. So, we designated these by a terms K, L, M, N, or we can also write as 1, 2, 3, 4. So, these are the 4 shells and these are called the 4 energy levels. Now, we want to calculate the maximum capability of electrons in these shells. So, we can write here the value of N, name of shell, then we will write about the number of electrons. Now, we have different values of N for a particular type of shell. So, we have a value for N 1, 2, 3 and 4, and the name of the shell designated to this will be shell number 1 will be K, L, M and N. Now, we see that the maximum number of electrons cannot exceed 2n square. So, substituting the value of N and calculating the number of electrons here. So, we have 2 into 1 square equal to 2. 2 into 2 square that will be equal to 8. 2 into 3 square that will be equal to 18. And 2 into 4 square that will be equal to 32. So, these are the number of electrons that any particular shell of an atom can accommodate. In K shell, we have 2 electrons. In L, we have 8 electrons. In M shell, we have 18 electrons. And in the last N shell, we have 32 electrons. So, this is the first rule of Bohr-Bury scheme, that the atom electron in an atom cannot exceed 2n square value. So, it is all about the first rule. Now, we will discuss about the second rule of the Bohr-Bury scheme, that is now the second rule is what will be the atom have. So, according to the first rule, we can fill the electrons in an atom according to 2n square, but there is a limit that we cannot exceed the last level from 8. So, in last shell, we can fill maximum of 8 electrons. In the first rule, Bohr-Bury said that the maximum limit of electron will be 2n square, but in second rule, it has a limit that we cannot exceed the limit of electrons in the outermost shell of an atom beyond 8. So, in last shell, we have only 8 electrons. So, if an atom has 8 electrons in the outermost shell, we can say that it's completed its full quota and we can say its octet is complete. So, we can write here, if there is an 8 electrons in the outermost shell, if we have 8 electrons in outermost shell of an atom, it means it's completed its full quota and we can say that it will follow a octet. It is called to be a octet. So, if an atom has a 2 electrons in the outermost shell, it means it constitutes only 2 electrons in the outermost shell, we can term it as a duplet because it has only 2 electrons. So, if an atom has a 8 electrons in the outermost shell, we can call it as a octet. If it has a 2 electrons in the outermost shell, we can call it as a duplet. So, these are the 2 rules of the Bohr-Bury scheme, and according to both of these rules, we can write the electronic configuration of any of the atom in the periodic table. If someone wants to copy it, please copy it now. So, now we will learn about the electronic configuration of different elements in a periodic table. So, here we have name of an element. Then, after name of the element, we will calculate the number of protons. Now we have number of electrons. Then we have number of neutrons. Here we will write electronic configuration. Then we will have its atomic structure. So, we will write the arrangement of the electrons in the shell of an atom from the atomic number 1 to 18. So, here we will write about the atomic number. So, arrangement of the electrons will be discussed from atomic number 1 to 18. So, now I am showing you how the electronic configuration of an atom can be written in a easiest way. So, our first element with atomic number 1 is hydrogen. Element with atomic number 2 will be helium. Element with atomic number 3 will be lithium. Element with atomic number 4 will be beryllium. Now, atomic number 1 means it will constitute only one proton, and the number of protons and number of electrons in the neutral atom will be same. So, now we want to calculate the number of neutrons. So, number of neutrons will be 1 minus 1, that is equal to 0. And we want to write the electronic configuration of that particular atom. So, it constitutes only one atom. So, its electronic configuration can be written as 1, that it can accommodate only K shell. So, it has only one electron in the shell. So, it can be distributed only the K number of shell. And we can write its electronic configuration as 1s1. 1s1 means shell number 1, that is S, and it constitutes only one proton. And its atomic structure can be drawn as, firstly we have nucleus in the center. We have nucleus in the center, and in nucleus we can write it constitutes only one proton and one neutron. So for hydrogen it can be drawn as a like this. Now we have atomic number 2 and the element here we have a helium. So for hydrogen we can write 1H1 and for helium we have 2He4. It means atomic number for helium will be 2 and its atomic mass will be 4. So number of protons here will be 2. Number of electrons are same as that of number of protons, and number of neutrons will be calculated by n is equal to z minus p, that is 4 minus 2, and it can be equal to 2. Now we want to write the electronic configuration of helium here. It has a number of protons 2. So it will again accommodate in the K shell and the electronic configuration will be 1s2 because K shell have a capability of maximum 2 electrons. So 2 electrons will be distributed in this. Now we will draw the atomic structure of that diagram. It consists of 2 protons, 2 neutrons. So it will be the shell diagram for helium. Firstly, we will discuss about hydrogen. Second, we have discussed about helium. Now, our third element is lithium. Lithium will having a symbol Li. It will have a atomic number 3 and atomic mass 6. So, number of protons will be 3. Number of electrons will also going to be same. Now we want to calculate the number of neutrons. Number of neutrons will be 6 minus 3. That is equal to 3. Now we want to write the electronic configuration of that atom. So electronic configuration will be 2K and 1L. Because maximum capability of K shell will be 2 electrons and it has a number of protons 3. So 1 proton will be shifted in the another shell. So its electronic configuration can be written as 1s2, 2s1. So 2 plus 1 will give the 3. Now we will draw the atomic structure of this diagram. We have 3 protons and 3 neutrons and 1 electron in the outermost shell. So we can draw it as 1 electron in the 2 electrons in that subshell and 1 electron in the outermost shell. So this will indicate the number of electrons. In this we have 2 electrons. So 2 electrons will be situated here. In case of hydrogen we have only 1 electron. So 1 electron will going to revolve here. So in case of hydrogen we have 1. In case of helium we have 2 electrons and in case of lithium we have 3 electrons. So 2 electrons will be accommodated in K shell and 1 electron will going to jump in the L shell. So it is about the hydrogen, helium and lithium. Now we will proceed to our next elements. Our next element is beryllium. So we will discuss it from atomic number 4 to 18. Now we have atomic number 4, 5 and 6. Atomic number 4 is beryllium, atomic number 5 is boron, and atomic number 6 is carbon. So, beryllium will have atomic number 4. So, number of protons will be 4. Number of electrons will be 4. It can be represented by the symbol Be4 and 9. It means atomic number 4 and atomic mass 9. So, number of neutrons will be calculated as 9 minus 4, that is equal to 5. Its electronic configuration can be written as 1s2, 2s2. It means it will have 2 electrons in the K shell and the 2 electrons in the L shell. It means 2K and 2L. Now we will draw the atomic structure for beryllium. We have 2p and 2n at the center. Now we have 2 electrons in the K shell and 2 electrons in the L shell. So we can shift here 2 electrons in the K shell and the 2 electrons in the L shell. So here it is our K shell and second it is our L shell. Now we will come to our next element. Our next element is boron, having an atomic number 5. So syntax for boron will be B, atomic number 5, atomic mass 10. So number of protons will be the atomic number of the element. Number of protons here are 5. Number of electrons will be same as that of the number of proton. Now we have to calculate the number of neutrons in case of boron. Number of neutrons will be 10 minus 5. Now we want to write the electronic configuration of that atom. So we have 1s2, 2s2, 2p1. After S shell, we can accommodate the electron in the P shell. So 2 plus 2 plus 1 will give a 5, that is number of protons. Now we have 2 electrons in K shell, 2 electrons in L shell and 1 electron in M shell. We will draw the atomic structure of that diagram. Firstly, we have nucleus here. In nucleus, we have 5 protons and 5 neutrons. So we can write it as 5p, 5n. Now its electronic configuration is 1s2, 2s2 and 2p1. So in K shell we have 2 electrons. In S2 orbit we have again 2 electrons and in the P shell we have only 1 electrons. So 2 electrons here, 2 here and 1 here, and it can be designated as K, L and M shell. So its electronic configuration is 1s2, 2s2 and 2p1. So students, now we have our fifth atom, that is boron, and boron can be written as B511. Now in case of boron, we have atomic number 5. So number of protons will be equal to 5. Number of electrons will same as that of the number of protons. Now we want to calculate the number of neutrons. Number of neutrons will be calculated as m minus p, that is equal to 11 minus 5 equal to 6. So its electronic configuration will be 1s2, 2s2, 2p2. It means it have 2 electron in the K shell and 3 electrons in the L shell. Now we will draw the atomic structure for that diagram. We have nucleus in the center. In nucleus we have 5 protons, that is 5p and 6n. Now 2 electrons in the K shell and 3 electrons in the L shell. We can draw it as, this is our K shell and this is our L shell. Firstly, we have 2 electrons in the K shell and 3 electrons in the L shell. So, it is about the boron. Proceeding to our next atom, that is carbon. We know symbol for carbon will be C. Carbon is having an atomic number 6 and it will have an atomic mass of 12. So, it can be written as C612. Number of protons in case of carbon will be 6. Number of protons will be equal to number of electrons, that is equal to 6. Now we want to calculate the number of neutrons. Number of neutrons will be the subtraction of 12 and 6. So number of electrons here will be 6. Now we want to write the electronic configuration of that element. So electronic configuration will be 1s2, 2s2, 2p2. Again we have in K shell 2 electrons and in L shell we have 4 electrons. So it will have a 2 electrons in K shell and 4 electrons in L shell. So 2 in K shell and 4 in L shell. I am drawing the atomic structure for this diagram here. In center we have nucleus. Nucleus is having 6 protons and 6 neutrons. So we can write 6p and 6n. Now our electronic configuration is 2 electrons in K shell and 4 electrons in L shell. Here it is 2K and 4L. So we have 2 electrons in the K shell and we can fit 4 electrons in the L shell. So here it is our K shell and it is our L shell. So it is the electronic configuration of numbers from 1 to 6. We will discuss the atomic number or electronic configuration from 1 to 18. So rest of the elements we will discuss in our next class. Thank you so much and have a nice day.